Hello friends, my name is Tushar. I am student at Indian Institute of Information Technology, Kottayam. I am going to show you the today's lead code daily problem with the explanation in C++ language. As I mentioned, I am student at IIIT Kottayam. This is my college. Today's lead code daily problem, June 13, 2024. Minimum number of moves to seat everyone. Let's move to the problem. As you can see, I'll read the description. Minimum number of moves to sit everyone. There are n seat and n student are in the room. There are n seat and there are n student in the room. You are given an array seat of length n. Your seat of length n is given, where seat of I is the position of the ith seat. You are also given an array student of length n, where student of j is position of jth student. Okay, and next is you may perform the following move in any number of times. Increase or decrease the position of ith student by 1. It means move the ith student from position x to x plus 1 or x minus 1. Return the number of moves required to each student to sit such that no two students are in the same seat. Note that there are multiple seat or student in the same position or at the beginning. So after reading the description, you might not get the idea of the question, but when you see the examples given, you will easily understand what they are trying to say and what they want us to do. So initially they gave us this seat array and the student array. So these both are arrays are given. So you can see the PDF here, where I designed the solution. Here you can see they gave us the seat array, so which is of size n, and the student array which is also of size n. Both are array. So we'll start with the solution. So first we are taking the first example 1, where seat first contains 315, students contain 274. So to visualize this problem, you can consider this as the seats are the position aligned next to each other. Or like I would like to say, you can see the 7 is the maximum most element in the both the arrays if you compare. So we are assuming that there are 7 seats in next to each other, and in those 7 seat, the seat, the if we see the seat array where 315 is given. So I am replacing the seat with this block, white block, and students with this character. So you can see they told that there is one seat on the position number third. So you can see this 3. I mark this 3 with this seat symbol. Next is 1. So there is a seat 1 position, first position, and there is seat on fifth position, as I mentioned, on fifth position, and there are students on second position. So there is student here on second position. There is position of seventh student is here, and there is fourth student is here. Now what we have to do, we have to give the seat to this student in such a way that we our algorithm should be optimal to give the answer. So you can see this for second number student can go to the first number seat and occupy that. Fourth number student can go to third number seat, and seventh student can go to fifth seat. So this transition will be just to one position. So we'll increase our counter to 1. This transition from 4 to 3 will also be just one the transition is required, or one movement is required, so this is also plus 1. But this required two movement from 7 to 6 and 6 to 5. So 7, 6, 5. So there are two transition from 6 to 7, 7 to 6 and 6 to 5. So two transition. So if we add this all, so this will be the 4. So you can see the output is the 4. Okay, you can see here. And if we take next example, the seats are 4159, students are 1326. So similar way, similar fashion I did. I represented 4 with the block, this block, 4 with this block, 1 here with this block, 5th with this block, 9th here with this block. So these square boxes are the number of seats available, and students are on first position. So there is one student on first position. Third, there is student on third position. There is student on second position. There is student on sixth position. Now, what we have to do, you have to move the student in such a way that they should do the minimum movement to reach their required seat. So, this first student, since he is already sitting on this seat, so no need to do the movement for this person. So, we'll just simply strike off this is not required. So, we'll not bother about first person. So now the next one. Now second person can go to the fourth seat also, and second person can go to the fifth seat also, and third person can go to fourth and fifth seat. Will do optimal. So the minimum most required. So third person can go to fourth position. That will take for one transition. We'll note this down. Second person can go to fifth position. This will be a movement of 1, 2, 3. So this will be the three moves you will require. So three will note down. And this fifth, sixth person will go to ninth seat. So 1, 2, 3. So this way, this the sixth person will go here. So if we add this all, we get 7. So 7 is the output required. For solving this problem, the approach will be we'll simply sort the both the arrays. So this will be the most optimal and easy to understand approach where we'll sort both the arrays, and after sorting the seat and student array, we'll get this like I'm taking the second example for understanding here. Uh, I have taken that example of student and seat. I sorted down the seat, so after sorting, it will be 1, 4, 5, 9. And after sorting student array 1, 2, 3, 6. Now what we have to do, we have to subtract the each position from seat and student. So if we subtract the 1 minus 1, it will be 0. If we subtract seat of student and current position of seat and current position of student, so we will get 0. If we do similar for next position, so 4 minus 2 will be 2, 5 minus 3 will be 2, 9 minus 6 will be 3, and if we add this down, so 2 plus 3 plus 7, 2 plus 2 plus 3, we'll get 7, and this is our required answer. So you might have understand now what to do. So I'll quickly start the coding part. So coding will be simple only, since this is not much complicated. So we'll start. So our initial target was to sort the array. For sorting, we can use our STL sort function, where seats dot begin comma seats dot end, and we'll do similar for the student array also. student students. Yes, so we sorted this down. So after sorting, we have to just do the subtraction of each position of student and seat, and we have to add. So for adding result, I'm declaring one variable sum equals to 0. Currently this is 0, and I'm running the loop from I equals to 0 to I less than. I can take seats length or student length. I'm taking seats length, seats dot size, comma I plus plus. Now what we have to do? Sum equals to sum plus. Now you should understand that we'll do ABS. Now why ABS? I'll explain. SCSC of I minus students of I. So, so I'm doing ABS to take the absolute position so that we get just magnitude. In case of the negative, we might get negative value of after subtraction. To avoid that, I am doing ABS, so that I am doing the ABS to be on safer side, so that I will not get the minus value anywhere, and I will return that, return sum. Now this should give me the desired result. I am running the test cases. Yes, you can see that both three of the test cases are passed, and now I am submitting my result. Yes, you can see my both the all the test cases are passed, and I am on comfortable side, and I got the accepted. So thank you for listening my video. You might have understand the solution. Thank you.